Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Welcome to this course, Introduction to SQL Programming or SQL Programming. This course is a presentation of Coding Bootcamps. My name is Jim Sullivan. I am your instructor. We do have a prerequisite for this course. It's Introduction to Database Design. If you need this prerequisite, please go back to Coding Bootcamps and look for information on the course Introduction to Database Design. Just to recap the course Introduction to Database Design, we discuss what was available before the advent of database systems. We looked at some fundamental concepts of database design, characteristics and benefits of a database, the types of data models, and we went over data modeling. We went through classifications of database management systems, and we discussed the relational data model, the entity relationship model, integrity rules and constraints, and ER modeling. Our first video, our first lesson is session 1. Here we will review functional dependencies. So as part of session 1, we will discuss functional dependencies, also the rules of functional dependencies, inference rules, dependency diagrams. So a functional dependency is a relationship between two attributes, typically between the primary key and other key attributes within a table. For any relation R attribute and Y is a functional dependent of that attribute X, usually the primary key, if for every valid instance of X, that value X uniquely determines the value of Y. So we can see here from these dependencies how the functional dependency relationship works. And inference rules. So Armstrong's axioms are a set of inference rules used to infer all the functional dependencies on a relational database. A union, this rule suggests that if two tables are separate and the primary key is the same, you can merge the tables, you can put them together. Now, sometimes that's a good practice, certainly sounds like a good practice. Maybe it's not. Quite often for performance purposes, a union may be the way to go, but sometimes performance indexes, there are other considerations that a DBA or an application architect or developer has to consider before making a final decision. Decomposition is the reverse of the union rule. So we take one table and we break it into two or more. If you have a table that appears to contain two entities that are determined by the same PK, consider breaking them up into two tables. Again, these are good rules to follow. They certainly sound like best practices, but there could be other considerations. And the dependency diagram. So a dependency diagram illustrates the various dependencies that might exist in a non-normalized table. So a non-normalized may be a database schema or a set of tables that are almost like compound tables, and they could be broken down. So sometimes we go through this process of normalization to break our tables down, to eliminate dependencies. Often that is a good practice, best practice, but again, there could be other considerations. In our next session, we are going to discuss normalization. Welcome back to our course. We are in session 2, and in this video, we are going to discuss normalization. So what is database normalization? So normalization should be part of any database design. So as the DBA or the data architect is going in, he or she should certainly take normalization into account. It is a part of the best practices of database design. However, it can be difficult to separate the normalization process from the ER modeling process. So the two techniques should be used concurrently. So obviously an enterprise model is not going to just appear already normalized. So as the enterprise is modeled relative to the entities, the relationships, when the data model is being developed, at the same time, that data architect or the person in the data architect role needs to take normalization into account. So the use of an entity relationship diagram, or ERD, will provide the big picture, or that macro view of the enterprise data and the enterprise operation. This is created through an iterative process and involves identifying all of the relevant entities and their attributes and also their relationships. So normalization is a procedure that focuses on the characteristics of specific entities and represents the micro view of those entities within the ERD, or entity relationship diagram. So normalization is that branch of relational theory that provides data insights. It is the process of determining how much redundancy exists in the data model or in the table itself. The goals of the normalization are to be able to characterize the level of redundancy in a relational schema and provide mechanisms for transforming the schemas in order to remove that redundancy. And if we haven't talked about it yet, just to review, a schema is the template for our data model. And there are typically considered to be 4 normalization forms. First normal form, second normal form, third normal form, and a variation of third normal form called Boyce-Codd normal form. In our next video, we are going to look at each of these normal forms. Welcome back to our course. We are still in session 2. In this video, we are going to discuss normalization, but a specific type of normalization called first normal form. With first normal form, a table should be such that there is exactly a single value in each cell of the table, and each record needs to be unique. So if we take a look here, we can see in this cell, this cell is telephone number, there are actually 2 values both of these cells actually contain 2 values or 2 telephone numbers. So right here, this tells us that since there is more than 1 value in each cell, we are not in first normal form. And if we look down here, we can see a way of breaking the table, the customer table, into 2 tables. That's certainly one approach, and using something called a foreign key. A foreign key was introduced in our last module that we delivered, or our last course that we delivered. And we can see here that the primary key for the customer name is now one of the keys for the customer telephone number, and this is now allowing us to have unique values in each cell and unique rows. Again, this is not the only approach, but this is certainly one approach. Please stay tuned for our next video, where we will discuss second normal form. Welcome back to our course. We are still in session 2, normalization, and in this video we are going to discuss the second normal form normalization. So a table is considered to be in second normal form. It is first in first normal form, and there is a single column primary key. So if we take a look here, we can see, we are tracking teacher ID really based on 2 unrelated items. The number of subjects that a teacher can deliver. And in this case, we can see teacher IDs. There's 2 teachers here who deliver more than 1 class, and that's very typical. And also the teacher age is unrelated to any subject that they teach. But if we look at this table here, we actually have a single column primary key, and we can see here we are tracking the teacher age and also the unrelated teacher subject. So this is typical where we actually have these two tables here where we can query information on either these related or unrelated data of whatever we are tracking. In this case, it happens to be teacher. So again, second normal form it has to be in first normal form, and then we need a single column primary key, and that's what we see here. We don't have a primary key in this table. So please stay tuned for our next video where we will discuss the database normalization of third normal form. Welcome back to our course. We are still in session 2, normalization. In this video, we are going to discuss a particular type of normalization called third normal form. In order for a database to be in third normal form, it number one has to be in second normal form, and there can be no functional dependencies between the data in any of the tables. So in this case, we can see there is a dependency here. If we look at these tournaments, we can see the winners, but we can also see the winner's date of birth, and we may want to be able to get the date of birth for the winners independently from knowing the tournament in which they were the winner. So if you take a look down here, we can see we've decomposed this large table into, in this case, 2 tables, and we're able to independently, just by knowing the winner, get their date of birth. And we can see here the tournament now is listing the year and the winner. So this way we don't have to know the winner and the tournament in which they were in order to get date of birth. So this is the third normal form. Again, it must be in second normal form, and there has to be no functional dependencies within any of the tables between any of the columns. So stay tuned for our next video where we will discuss a special form of third normal form called Boyce-Codd normal form. Welcome back to our course. We are still in session 2, normalization, and in this video we are going to discuss Boyce-Codd normal form. So Boyce-Codd normal form is a special type of third normal form that is slightly stronger than third normal form. Boyce-Codd normal form was developed by Raymond Boyce and aggregate to address certain types of anomalies that are still present within third normal form. So if we take a look here, we can see shop near a person, we can see the person and the shops, and then we can see the shop and the shop type. So if we then bring this into third normal form, we still have the shop and the shop type here, but we're able to eliminate some of the data anomalies by, and in this case, we still have the person. And now we're adding the shop type, which is a key which exists in both tables. And then we're also able to put in the nearest shop. So this actually addresses those kind of anomalies where we could have duplicates as far as shop type. So this allows a user then to drill down to the nearest shop. And if we take a look here, here is a simpler way to state or to display Boyce-Codd normal form. We have our student ID table here, our student table. We can see our student ID. And if we look here, we have our professor table, and we can see the professor IDs. And the professor ID is a foreign key within the student table. And we are able now to bring back the professor and also the subject that the professor is teaching. So this is a more simplified way or a simplified view to look at Boyce-Codd normal form. So, normalization and database design,
Thanks for watching. Feel free to add your questions as comments down below.
the data architect certainly wants to take normalization under consideration when designing the database. So during the normalization process of the database design, make sure that the proposed entities or tables meet the required normal form before table structures are created. If that's not done, the data architect can have a lot more work going back in and breaking the tables into the required normal form. Many real-world databases have been improperly designed or burdened with anomalies if improperly modified during runtime or during design time. You may need to be asked to redesign any existing tables, and this could be a large undertaking. It can be a lot of rework if the tables are not properly normalized. So stay tuned for our next lesson and our next video, where we are going to look at the database development process. Welcome back to our course. In this lesson, session 3, we are going to discuss the database development process, and in this video we are going to cover the software development lifecycle, waterfall, database lifecycle, requirements gathering and analysis, logical design of the database, and implementation and populating the database. So this is no way to imply that Agile could not be used, but since most architects and most developers already know waterfall, we'll focus on waterfall. So with the waterfall process, typically there is one iteration with phases. Here are the phases now: requirements analysis, system design, implementation, system testing, system deployment, and system maintenance. So, and there is, this does work. It's not bad, but there are obviously many success stories with an Agile approach as well. With the database lifecycle, we can use the waterfall cycle as a model for the database development process, but it does incorporate some assumptions. We can separate the development of the database, specifically from the creation of the schema. Again, a schema is a template to define the data in the database from the user processes that make up the use of the database. And we can use the 3 schema architecture as a basis for distinguishing the activities associated with the schema. Again, the schema is a template. It is the tables, the columns, the data types, and so on. We can represent the constraints and enforce the schematics of the data once within the database, rather than within every user process or every user action that actually uses the data. So the database lifecycle steps, again, similar to waterfall: requirements gathering, and the analysis of those requirements, the logical design, so that would be developing the schema. Implementation would be then taking that schema and building it into some kind of a database management system, such as SQL Server or Oracle or MySQL. Realizing the design, and then finally populating the database or entering data into the database. And guidelines for developing that ER diagram. An ER diagram is a model of our database. It's a model of our enterprise. It lets us know what data we need. So certainly we want to document the entities discovered during information gathering, document all of the attributes that describe that entity, and identify attributes and primary keys. Develop an initial ER diagram and get feedback on it. Make sure it's correct. Create new entities, which will eventually become tables, for multi-valued attributes and repeating groups. Incorporate these new entities in the ER diagram, and again, get feedback from the users or from the business, and then verify the ER model by normalizing the tables. And take a look at our last few lessons where we discussed normalization. So please stay tuned for our next lesson where we will discuss database users. Welcome back to the course. This is session 4, and in this video we are going to discuss database users. So the end users of a database can be described in many different ways. There's actually a different taxonomy for the various end users of a database. Interesting. So the application user. So anybody who uses a typical social media application, Instagram, Facebook, Snapchat, there's a database behind the scenes. We may have heard the term web server, and nothing is kept on, no data is kept or nothing is saved on the web server. The web server is runtime only. All data is kept in the database. The users don't directly interact with the database. So all of that data is called by the application and then presented back to the user. The user can't update the data, but it's all through the application. So Uber, you name it, most mobile and web applications, if not all, are running on the web server and database model, that type of application. A sophisticated user may be somebody who needs reports and is able to actually build a report. A lot of applications come with report builders. They may not be programming in the database queries, but they're able to format what kind of output they want. And then that the building of that output actually goes back to the database and makes a call on the data and then returns the type of data and report that the user needs. Application programmers are also end users. They need to understand what tables are present, what columns are present, and they need to know from the enterprise how the data needs to be presented back to the end user. The application programmers need to understand the schema or the template, know where all the tables are, the columns, so that developer then can correctly build that application so the end user is able to, or the user of the application is able to enter the data or retrieve the data that he or she needs. And then finally, database administrators, they run the repository product that actually manages our data. So they are really in charge of backing up the data, making sure it's correctly formatted, that it's properly entered, that the schemas are built correctly. So this is a really good representation of database end users. And again, end users can come in many different categories, and it's really where that end user is in the product development process, where that user is will dictate where they end up in one of these 4 categories. So please stay tuned for our next session where we will begin to discuss the SQL language, structured query language. And this is almost a universal database language. Welcome back to our Introduction to SQL Programming course. We are in session 5. In session 5, we are going to take a look at SQL, or structured query language. This is video 1, where we will discuss creating a database. So when we are creating a database, we obviously need a database, and our examples are going to be shown using the Maria database. So here we have the Maria database. This is the web page. It's at mariadb.org. The Maria database is what we call a fork of MySQL. It is a completely open source community. You can read about it or look at some videos, and obviously you can click on the download button and download the Maria database. This is the Maria database once it's fully installed. You can see the prompt here indicates that it is the Maria database. The database name will be in here in these brackets in the prompt. We haven't created the database yet, but when we do, we'll actually see it in there and when we connect to it. There are tools that run on top of the Maria database, which are graphical or visual tools. However, it's almost it's very, very difficult to completely get away from the command line. However, there are plenty of tools that make it so the command line is something that you'll use very rarely. Again, in this video, we are going to look at the create database command in structured query language or SQL or SQL. And one place to look if you want to understand the commands or learn the commands is the product documentation or the vendor documentation. Here we have the Maria database documentation. We can see here create database. And it could be just as simple as running the create command and giving the database a name. Back here at the database command prompt, we are going to enter the command. So just like we saw in the documentation, it's going to be create, and we have to pass database because the create command can be used for tables, for columns, for other things. So we have to, one of the parameters is going to be database. So we have create, and our parameter is database. And we are going to give the database a name, and here we're going to be working with a business application, so we'll call it business app. And we have to terminate with a semicolon, and there we go. And what we will do at this point is do use, we're going to use business app. And we'll see the database has changed, and now we see that we are connected to our database business app. So in our next video, we are going to be discussing the creation of tables. Welcome back to our structured query language or SQL programming course. We are in session 5. And in session 5, we are going to look at the create tables command. So when we want to create a table using structured query language or SQL, we can see the command there, create table, and then we pass in the table name. But tables have columns, so we have to define the columns. The columns have names, they have a data type, and there's also an optional constraint. And then finally, we see at the bottom, there are optional table constraints as well. So we need at least one column. So we'll go through an example where we will use fairly generic, simple, well-known data types and constraints. We will go into the data types and constraints in following lessons and following videos. But for right now, for this example, we will just use basic data types and column constraints. So we'll start off again at our command prompt, and there is a command called show databases. And what we need to do is connect to one of the databases. So we'll use the use command and type in the database. And now we are connected to our business app database. Here we are back at our database command line. So here we are going to pass the command where we create the table, and we're also going to again pass the constraints and the data types, and that is all part of the command for creating the tables. This is all necessary data. So let's come back in here and we'll pass it. We'll take advantage of the way that we can actually insert some line breaks in here, just so this can make a little more sense. So we have the command here, create, again, table, and the name of our table in this case is projects, and our
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
column name here is project ID. It is an integer, and we're going to put a constraint on here to auto increment, and then we have a comma for the next column. Project name is the name of the next column. Varchar data 255. This is a character, character data type that is 255 characters in length, and our constraint that it can never be null. And here we have begin date, and that is a date data type. End date, that is also a date data type. We have a cost, which is a decimal data type here. We're passing in the length of the data type, and again, that is not null. And then we're using a timestamp here, so we're saying the default current timestamp. And then we have a table constraint here called primary key, and we're passing in project ID. And the primary key is what makes each record in the table unique. So, and then we're closing the command with our close parentheses, and then using the semicolon as a terminator. And so let's go ahead and run this command. And we can see here that the table was created, and what we can actually do here is run a command called show tables. And we can see here projects is one of our tables, and we can actually do show columns from projects, and it'll show us here all of our columns, column names, the data types, and all of the constraints. So we can see here the primary key for the table. We can see the data types here that we passed in. We can see the column constraints. We can see here any extra functions that are running. So we'll take a closer look at the data types and the constraints in an upcoming video for this session. So stay tuned for our next session, where we will continue discussing the SQL language. Once again, welcome to our introduction to the SQL programming language course. We are still in session 5. In this video, we are going to discuss SQL data types. So we saw in our previous video an example where we actually passed in some data types, such as integer, such as what they call varchar, or that could even be variable character. We can see here some other popular and other useful data types. The integer, we can see here, has a range. So you can see here, if you need this particular range, you can use an integer data type. There is a small int, which takes up less memory. So integer takes up more memory because the range of numbers is bigger. So if you need that range, obviously integer is your solution, but it can cost you, because it can cost you in performance and storage. So a small int may be a better way to go. As you can see here, the range is less, but it takes up less memory. And there's a tiny integer, which only goes from 0 to 255. It doesn't contain negative numbers. These two, the int and the small int, allow you to use negative numbers. There's decimal. So if you need some kind of precision and you need decimals, obviously decimal. Numeric can also be a synonym for decimal. A timestamp. We saw an example of a timestamp, and a unique identifier, sometimes called a GUID, is also a different data type. We also saw date as a data type, but for more data types, please consult your learning materials. And I listed here some of the results from our previous demonstration here. So we can take a look at the data types we actually used. For this table, again, we saw integer with a length of 11, varchar here with a length of 255. We can see the date data type, the decimal. So here's an example of the decimal. And then we can see timestamp as well. And date and timestamp are different. And we can see some defaults that go off, again, for this particular column. So there are obviously, just like we just saw, there are more data types. And your data type should be considered for the type of application you need, for the type of data you need. But also, you want to be careful that you don't use something that could take up much more memory than what you need. So you want to pick a data type that allows your application to be as efficient as possible, but still meets all of the requirements. So stay tuned for our next video where we'll actually discuss column constraints. This is the Introduction to SQL Programming course. We are still in session 5. In this video, we are going to look at optional column constraints. So the optional column constraints are null, not null, unique, primary key, and default. They are used to initialize the value of a new record. So the column constraint null indicates that null values are permitted, which means that the row can be created without a value in that particular column. So this is a way of actually controlling and managing our data. That way we get these constraints out of the box with the database. That way the developers don't need to go in and enforce these rules with the application code. The DBA or the data architect can control at least control the data and how the data is presented to the user in accordance with the business rules right at the database level. The column constraint not null indicates that the value must be supplied when a new row or record is created. So here, if a user does not insert some data that's required, that's not null, that error can be caught at the application level, at the code level, and a message can be sent back to the user that they must provide data or they're not going to be able to use that particular feature. So let's take a look at an example. Here we are again at our database command line. And this is just going to be one example. We can see here about the null values and some of the default values here. You can see that we do not permit null values for the project ID or for the project name. We are permitting null values for the begin date and end date, and that makes sense because at the time you can certainly create a project without knowing exactly the begin or the end date. You may not know the cost immediately. That can be added later. And we can see here with the timestamp that cannot be null, but we are adding here a default value for it. So interestingly enough, we can see here that the default is null when we don't allow a null value. That is it's something you have to just understand, and sometimes you have to look at both of these columns to really understand, is the default relevant in this case. Here we can see that the default is really only relevant here. For these yeses where null values are permitted, obviously here we can use this null here, but where they are not permitted, the default here is irrelevant. That's just one thing to look out for with database programming. Sometimes the default doesn't match up with the constraint. And stay tuned for our next video in this SQL programming course. Welcome back to our Introduction to SQL or Structured Query Language course. This is session 5. In this video, we are going to discuss table constraints. So table constraints are constraints at the table level as opposed to the column level. So an identity constraint is any constraint that gives each record its own unique identity. So the unique constraint prevents duplicate values from being entered into the column. So each column is unique. Both the primary key and unique constraints can be used to enforce entity integrity. Multiple unique constraints can be defined for a table. So this is enforcing data rules of the enterprise. Again, these are rules that can be implemented at the database level. So these rules don't need to be coded at the application level. When a unique constraint is added to an existing table, the existing data is always validated, and feedback can be delivered to the database programmer or database administrator at that time if there are any violations. And then they'll have to take action. A unique constraint can be placed on the columns that accept nulls, and only one row can be null. So with a unique constraint, you can have a null value. With a primary key constraint, there are no null values accepted. Primary keys always have to be non-null. A unique constraint automatically creates a unique index on the selected column. So let's take a look here at a demonstration. So here we ran the create table command, and we did it in multi-lines just to make it easier to view. And as we can see here, from this command, we ran, again, the create table. We can see the columns and their data types that were passed in and the constraints on the columns. We see here we have a primary key in ID. So this ID is going to be constrained there, and that always has to be unique. And then we have a unique key employee code. So this employee code is a unique key. If we list or show the columns for employees, we can look over here. ID is primary, and no nulls are permitted. So that is the abbreviation for primary. And if we look here at employee code, we can see the data type. In this case, no nulls are accepted, and we can see the unique key. So we can see what's being enforced there. Another table constraint is the foreign key constraint. And the foreign key constraint defines a column or combination of columns, that's important, whose values match the primary key in another table. So the foreign key is that link between tables, and it is also how the tables relate. So a data architect must analyze the enterprise and let us know how the tables relate. So values in the foreign key are automatically updated when the primary key values in the associated table are updated or changed. So that's convenient. Foreign key constraints must reference primary keys or the unique constraint of another table. The number of columns for a foreign key must be the same as the primary key or unique constraint, so they must be consistent. If the with no check option is used, the foreign key constraint will not validate existing data in tables, so that's important to know. No index is created on columns that participate in the foreign key constraint. So let's take a look at a table here with a foreign key. So this is a demonstration here. We created a table, product order, and it is relating back to the customer ID in the customer table. So this, and we can see the reference here again. So we created this, we just ran this command, we used a multi-line approach just so it's easier to view and understand. And we can see here we have the product order relates back to a customer ID, and that makes perfect sense. If a customer has a order, we want to know which customer that order is for. And the foreign key also gives us that link back to the customer table, so we can list the attributes of a customer without duplicating them in this table. So that is a key convenience that the foreign key gives us. If we list here product order, we can see that this mul or multiple here is being used. And if we look up here, we have another foreign key in product category and product ID, and we can see what it references. And that also is another relation as well. And with a lot of databases, you will see the term under the key mul or multiple, and that is the foreign key. It's not it doesn't say foreign or anything like that for different reasons, but the foreign key is indicated by.
Thanks for watching. Please like and share this video.
Multiple, so we can see product category is a foreign key, customer ID is a foreign key, and we can see they are indicated down here with the mul indicator, which stands for multiple. And multiple is a correct term. It has multiple references. The check constraint restricts values that can be entered into a table. It can search conditions similar to a where clause in a SQL statement, and we'll get to where clauses, but it just looks for certain conditions. It can reference columns in the same table. The data validation rule for the check constraint must evaluate to a Boolean expression, meaning true or false. It can be defined for a column that has a rule bound to it. And the default constraint, as the name implies, a value is supplied automatically and added to that column if the user does not supply one. So a column can have one default value, and the default constraint cannot be used on columns with a timestamp, data type, or identity property. Default constraints are automatically bound to a column when they are created. So when the column is created, that's when the default is added. Let's take a quick look at this demonstration. Here again, we created a table, contacts, and we can see here that we added a column, contact group. We see the data type here, variable character or varchar 50, and we have default, and we're entering text here. Probably the most well-known or automatic type of default is null. Sometimes it's actually in conflict with the null column, whether null is permitted or not, but a lot of times you'll see the default will go to null. In this case, you could see here we passed default general. So if we don't supply data for contact group, the database will automatically supply the text right here, general. Now the default can be overridden on when data is inserted by simply inserting data into that column, but this is the default, and there are many other variations of default. So we could see here in this extra auto increment, we're using an integer, but it automates the you can see here it automates the increasing of the ID here, so that will always be unique. So there is a default there as well, but it's not under the default column. So that's something else to understand. Welcome back to our SQL programming course. We are still in session 5. And in this video, we are going to discuss user-defined types and altering tables. So a user-defined type is very similar to a class in object-oriented programming. You define the columns, the data types, similar to defining the attributes and the data for objects in object-oriented programming. User-defined types are always based on system-supplied data types. They can enforce data integrity. They can allow or not permit nulls. Not every database management system supports user-defined types. As of the making in this video, MySQL and Maria database did not support user-defined types. And let's take a look at the alter table and drop table command. So you can use alter table statements to add or drop constraints. Alter table also is what you use to add or remove columns. When a constraint is added, all existing data is revalidated in the table for violations of that constraint. So you may get some feedback and you may have to take action on that data. The drop table command will remove the table from the database, so obviously make sure you are connected to the correct database. Let's continue with a demo. So we've connected to our database, and we will create a table. We can see there with the constraint, and we can show the columns. And we can see here the primary key, the defaults, and the auto increment. So let's continue here, and now we're going to run alter table and modify a table, and we can show the columns again, and we can actually see here that the data type is different. So it's a different data type, and it's a different size too for the same field. And we can also drop a table as well. So if we decide we don't want this table anymore, we have this table T1, so we can use the drop table command, run that, and that was successful. And if we look at show tables, T1 will no longer appear. Welcome back to our Introduction to SQL Programming course. This is session 6, the data manipulation language. In this video, we are going to discuss the select statements in the structured query language, or SQL. The SQL programming language can be broken into two parts. There is data manipulation language, which is called DML, and there's also data definition language, which is DDL. And DML is used to query and modify the data in the database. In this session, we'll describe how to use the select, insert, update, and delete SQL DML commands defined below. So we'll see here again, select, insert, update, delete. In this video, we will be focusing on the select statement. In the SQL DML statement, each clause in the statement should begin on a new line. The beginning of each clause should line up with the beginning of other clauses. So they should actually be counterparts or corresponding parts. If a clause has several parts, they should appear on separate lines and can be indented under the start of the clause to show the relationship. Uppercase letters are used to represent reserved words. Lowercase letters are used to represent user-defined words. However, SQL does not enforce the uppercase and lowercase. These are merely good practices or conventions that the industry follows. If we look here at the select statements, again, we can see select items. So these will be the columns. You can pass other items besides columns, but for right now, we'll say we're selecting table columns. We can select all of the columns. We can select just some of the columns from the tables indicated, where, and then we pass in a condition, and then we can actually group these to format the results. So we can group by a particular field, say it's name or status, and then we can order by, meaning that we can sort. So we can sort by alphabetically, numerically, and we can even go beyond these commands here. So select statement alone, and we can have a select statement alone, and we can also have it with a where clause where we pass in criteria. We can use wildcards, and we can use a like clause, which also limits a wildcard. The select statement with an order by clause, again, that gives us sorting. A select statement can also have a group by clause, which can roll up certain row results by a column value. And then we can also restrict rows by the command having. Let's take a look at a few examples. In this example, we'll run a basic select statement. So we can see here we're running the select, and we can see the select is a reserved word in all caps. Here are the columns separated by commas, the columns of the table. I know the columns of this table because I listed them, and then we see the from keyword again in caps, and we know the table is employees, and we have our terminator, which is our semicolon, and we can go ahead and run this, and we can see the results here. We can see the column names and each record. We can also use the select statement to return just the columns we're interested in. So here we see, although the columns here are 6 columns, we're only bringing back, in this case, 4. So we can run this select statement, and we will see that in this case only 4 columns are brought back. Here we have an example where we are actually using the where clause to pass in some criteria for the results returned. In this case, after from employees, which is again the table, we're going to say where the column employee code, in this case, equals E34, and I'm using single quotes because the data in this column is the variable character or varchar character, so we have to pass it with single quotes. So if I run this query, we should see that only the results where the employee code equals E34 are returned, and that's what happens. In this case, there's 1 record returned. In this video, we're going to take a look at the like clause. And because there is some syntax involved in the like clause, particularly here where we can see the percent signs used as wildcards. But here we know that the last name is, again, a varchar character, so we still need the double quotes. And then we have a string in here that we suspect matches data in the table. So we put in what we know, and then we bracket around it these percent signs, wildcards, which I'm running this out of Windows, and they could be different in Linux. So please check the database documentation just to see what type of wildcard is used by your operating system. So we're going to go ahead and run this, and we can see here that last name, we can see that this string here matches the middle characters here, so that's why this one it was true and this result was returned. Here is an example with the select statement and using order by, and in this case we're going to order by last name. So we have the table listed here, the default listing, and we're going to run order by last name, and we should see the results to be returned alphabetically by last name. Go ahead and run these, and we can see here we're just returning a subset, but we can see here that the order has changed about how the table records are sorted. And here's a good example of how to use the group by command here in the select statement. We are going to look to return only the positions, and we want to know exactly what positions we have in the database, so we'll group by position. So we can see here we actually have 2 analysts, so it can be hard to read after a while. So if we want to get a listing of the unique positions, we'll just return position in this case. So we'll say select position from employees, group by position. And we'll see here that indeed we only have these 3 distinct positions in our database. In this video, we're going to take a look at the having clause, and again, the having clause adds a condition to 1 or more of the columns returned. In this case, again, I broke the select statement into sections because there, again, is some syntax and it can get long. So we're returning these columns of the table employee, And in this case, we want to bring back the first 4 employees to ever join the company. So we have our ID that increments by 1. So I know that rule. And we'll say here having ID is less than 5. So the rule here for true is going to be IDs that are less than 5, not less than or equal to, but less than 5. So if I go ahead and run this.
Thanks for watching. Feel free to add your questions as comments down below.
You can see here that that's what happened. So we brought back the data, these columns, on employees whose ID or having the ID less than 5. Welcome back to our Introduction to SQL Programming course. This is session 6. This is the Data Manipulation Language, or DML. In this video, we are going to discuss the SQL insert statement. So there are multiple ways to structure the insert statement. Here we're going to look at the insert and value structure. So the insert statement adds rows to a table. In addition, insert specifies the table or view the data will be inserted into, so we have to specify the table. Then there is the column list, and that's the lists of columns that will be affected by the insert. A column can be omitted, but it will need to have some kind of a default associated with it if it is omitted. If there is no default value, it's possible that an error will be returned. If you are including columns, they can be listed in any order in the insert statement. The values section of the statement specifies the specific data that is being inserted into the records. So values is required when using insert values. Here is the syntax of the insert statement. So we can see here, insert into table name. A view name is a virtual table, and then a column list right after that. And then if we're using values, we need that value list. We can also pass a select statement that selects data from a different table. It's got to be selected properly so it matches the column list. But this is also an alternative way, and sometimes a faster way, particularly if you're migrating data from an existing table. When inserting rows with the insert statement, these rules generally apply. Inserting an empty string, again a string, we need to pass the quotes with the empty quote character. We would pass that into a varchar or text column, and then it maybe insert a space or a null. There can also be defaults as well. All column characters are right padded to a defined length, and it's important to know you've got to pass the data as it is defined in the database. All trailing spaces are removed from data inserted into varchar columns, except in strings that contain only spaces. These strings are truncated to a single space, so that's important to know. If an insert statement violates a constraint, default, or rule, or if it is the wrong data type, the statement fails, and the SQL server, in this case, not the product, but just the generic term, returns an error message. When you specify values for some of the columns in the column list, one of 3 things can happen to the columns that have no default value. So a default value is entered if a column has a default constraint, if a default is bound to a column, or if a default is bound to an underlying user-defined data type. Null is entered if a column allows null and no default value exists for that column. An error message is displayed and the row is rejected if the column is not entered properly or is defined as not null, or if no default exists. Again, if an integer is entered incorrectly, say with a character that's not an integer, an error message will also be returned. Let's take a look at an insert statement here, insert values. So here, this table is called classes, and we can see 3 columns here in the classes, but notice the class ID is auto increment. So, and it's also the primary key. So the database is going to take care of entering the class ID for me. So when I come down here to our insert statement, we have insert into, and the table name is classes. Our column list in this case only has to be class name and student count, again, because the database is going to take care of inserting the class ID for me, and our values are going to correspond to the order here. And again, these don't have to be any specific order, but the order here has to correspond. So the first, the value of the data here is the class name is going to be chemistry 210, and the student count is going to be 105. And we can go ahead and run this, and notice here it's an integer, so I have to use an integer here. So I'm going to go ahead and run this, and that data wasn't inserted. And again, we can do a select star from classes to see our inserted data right here. And we can also run an insert using a select statement. In this case, we also have a table that is very similar that we want to migrate some data from, called just class. And we can see here it's structured and built the same way, but we need to take a look at the data that's in here, and we want to insert this data into our classes table. So we can do that using an insert select. And here is our example of using an insert with a select statement. So again, we're inserting into classes. We're able here to take a look at the classes. We see there are 4 records currently in the class table. We can see that the data does match. So we should be able to run this select class name, which is one of the columns, and also student count. And again, their data matches the classes table. And we can see again there are 4 records in here, so we should have 4 more added. And so we again are going to insert into classes, but we're going to select the data in the class name and student count from the class table. And again, we do not have to pass our class ID for classes because that is given to us automatically by the database. So that went ahead and ran. And if we do again our select star from class as, we can see that this data 200, 210, 220, which is, these are big classes, big student counts, possibly remote. We can see here that they were all added, database applications, database reporting, and they were all very easily added to the classes table.
Welcome back to our Structured Query Language, or SQL, programming language course. We are in session 6, SQL Data Manipulation Language. In this video, we are going to discuss SQL update statements. The update statement changes data in an already existing row, either by adding data to an empty column or by modifying existing data. Here is the syntax. It is update and then the table references, and then we want to set the column names equal to some data. And you can see here there's a list of columns, comma separated, and then there is a where condition. So you could pass in here where ID has some kind of a value, and only that record or set of records will be updated with new values. So let's have a look at an example of an update command, a typical update command. This is where we have update, the name of the table, and this is the table we're updating. We're setting class name, this is the column, equal to database reports, where class ID equals 3. So if we see here where class ID equals 3, we can see the old value, and we want to change the value of class name to database reports instead of database reporting. So we can go ahead and run that, and that was successful. And so now we can go in and list the contents of this table. And we can see here that the value of class name has been changed for the record where class ID equals 3. Here is a different approach for an update. This is an update. We're updating a different table here called classes. We still want to change that column name here. We see database reporting, but instead we're going to use a subquery from a different table. In this case, it's class, where we're just updating the value. So here we could say that we know the current name, but we want to make sure that they are the same. And one of the best ways to do that is to select the data directly from that target table. So this is the command here. So this subquery is going to run return one value and place it here as the new value of class name, and then this where clause will come in and update the value for the record where class name column equals database reporting. So let's go ahead and run this query. And that was successful. And if we do this select star from and classes, we'll see that indeed that the update to the data for table classes has been successful.
Welcome back again to our SQL programming course. We are still in session 6. In this video, we are going to discuss the delete statement in SQL. The delete statement removes records or rows from a table. Delete names the table or view, and again, a view is like a table, it's a virtual table. But delete names the table or view that holds the rows that will be deleted, and only one table or row may be listed at a time. The where clause, that's the standard where clause, and it limits the deletion of the record set. So you don't have to delete every single record. You can just delete records where a certain condition is true. Some rules for the delete statement. If you omit a where clause, all rows in the table are removed except for indexes and table constraints. Delete cannot be used within a view that has a from clause naming more than one table. Delete can affect only one base table at a time. Let's have a look at an example. So again, we have our classes table, and we decide we want to remove this class that's just called math. It doesn't sound very descriptive. So we'll rename it later, but we're not going to offer it right now. So we're going to enter this delete from the name of the table, classes. And we're going to use the where clause as a record selector, so where class name column equals math, and I have to use the single quotes because of the type of data that's there, and I have the semicolon as a terminator. So we'll go ahead and run this, and that ran successfully. So again, we'll go select, in this case, star from classes, and we'll see that the math record, only one record's been removed. We had 10 rows earlier, 10 records, now we only have 9. And that full record that had the class name of math has been removed. Stay tuned for our next lesson. Welcome back to our Introduction to SQL Programming course. This is still session 6, Data Manipulation Language. In this video, we are going to discuss the SQL built-in functions. So SQL does come with
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
a group of built-in functions very similar to most programming languages, if not all the popular programming languages. Things such as sum, average, string conversion, and other string manipulation functions. So aggregate types of functions, they return summary values such as max, min, average. Conversion converts one data type to another. So number 10, that's string data, can be converted to an integer. 10.1 real can be converted to an integer, which would just be 10 in that case. Date converts data to a date, but it has to be formatted in a way it can be formatted to a date. And if you don't pass that, the system will return an error. It has to be able to use a 12-month year, obviously. You can't have numbers that would convert days of the month to higher than 31 and so on. So there are going to be a lot of rules for date conversion. So you may have to go through and make sure that you're formatting. And a lot of times you pass what's called a text mask that you use for your date formatting, and you may need to check that based on the database you're using. Again, mathematical functions could be things like min, max, count. So there are, so take a look at the different mathematical functions. String performs operation on character strings and binary data. So you can even do substrings with built-in functions. System returns certain database system data, so system specific, and text and image performs operations on text and data that's stored in the database. Here are some of the base built-in functions that come with SQL. Database providers such as Microsoft may include others, but we have the AVG function, the count function. So this averages a listing, whatever's passed to it. The count returns a specific count of whatever's being passed. Max returns the maximum value in an expression that's passed to max. Sum sums up only the distinct values in an expression. So again, these are the base functions, and there are more than just this, so please consult the documentation for the database that you are using. These can be quite useful. So let's have a look at some examples for the aggregate functions. So we'll take a look at this table here we'll take a look at the classes table, and we can see the record set there. So it's returning 9. So the first function that we want to take a look at, let's look at the count function and just return the row count. This is something that can often be quite useful. So let's pass in select count from classes, and we're going to count all the records. And we have 9 back, and our original listing agrees with that. So that's the count function, which can often be very useful. And let's try the sum function. So instead of, we want to get the sum of student count. So let's take a look here again, and we can see student count column there. So let's do select sum of, and we have to pass in the column. And from classes. And so this is returning a sum of all of the student count columns. And let's take a look again at, maybe we'll run the average There we go. There's the average student count. And right there, that's the average in each class. Still quite large. So these are some of the functions. Again, we can also run min and max. Let's try max first. We can see here the max, and we can also run the min. So again, these are some of the functions that come with this particular database, and these are the base functions that come with SQL. You need to consult the documentation for the database you're using for other functions. Let's take a quick look at the convert function. So the convert function is not as useful as other functions. However, it can be key in some situations. Let's take a look here. We've already listed this table, but let's take a look if we actually convert the student count to time. So the student count makes more sense if we convert it to time, and you can see there it's starting off 101, 102. So if we convert it to time, you can see what it does. It converts it using 24-hour time to the format that the string will fit, and that's important to know. And as you can see here, we're doing more ad hoc type of selections for our application. In this case, we're selecting the result of 2 minus 4, and we're converting it to signed data. So that's really what the conversion will do. Notice we're not picking from any table here. And there's our result. Another useful function that's great for applications are the date functions. There are several date functions, but we'll take a look at just one of them here. In this example, we are passing a string, and you can see this is a string, but it's formatable for date. And you can see here we bring back this date. Here is another really useful set of functions are the subtract date, add date. We'll take a look at subtract date. Here we're passing in a date, and we are subtracting 31 days off of that. Now that can be really useful because it's highly relative, and it can be very useful for applications. So if we pass in the argument just like we see here, we're going to take 31 days off the date January 2nd, 2021, and you can see here we're back at December 2nd, 2020. The SQL mathematical functions are functions that are also quite useful. Here we can take a look. We can actually call some of the addition, multiplication, subtraction, and modulo functions, which can return useful data back to our application. So here we can see we're using the addition function. So we're selecting 3 plus 5, and we can see the result. Here we have an example of the multiplication. There is multiplication operator in here. Sometimes it's a little easier to see if we enter a space. So we are multiplying these two long numbers, or these two big numbers. So it's almost like multiplying that. Well, we are multiplying them together, and we're getting that result right there returned by SQL. Here is the division function, and notice in this case we're going to try to divide by 0, and we get null back. So if we come in and we update this appropriately, and we get that result right there. So we can see that that is a result of dividing 300 by 6. We can also set precision. So here you can see here we can set the division precision. So, and then we'll try it one more time, and you can see here we get the precision, or the characters to the right of the decimal, to the precision of 6. And we can see the modulo here, so we can return the remainder of the two divisors here. So if we have one number divided by another, we can actually return the remainder, which is useful for applications like determining if a number is even, or there are multiple useful purposes or items that are useful from modulo, and there it is right there. Welcome back. It's been a pleasure presenting to you. We are in our last session. This course is Introduction to SQL or SQL Programming. We are still in session 6. In this video, which is our last video, we are going to discuss table joins in SQL. So joining tables, joining two or more tables is the process of comparing the data in the specified columns and using the comparison results to form a result set, which is the result set is a new virtual table from the rows that qualify. So we get a result set back. A join statement specifies a column from each table. It compares the values of those columns row by row and combines rows with qualifying values in the new row. So yes, the result comes back. We can see the records. It looks like a table, the result set that comes back, and it is a virtual table. In some databases, it's called a cursor. It can be used like a virtual table. You can actually perform select and other types of SQL statements against that result set. When these are the types of table joins. There are inner joins, there are left joins, there are right outer joins, full outer joins, and cross joins. We'll take a look at each one of these. Let's have a look at the inner join for, in this case, it's going to be two tables. So we can see here the result is going to be the intersection, or where the columns, certain columns are equal. So we'll return all records where the condition or certain columns are equal. So we can see here we have a select list, which is the columns from the table here, which is going to be the table on the left. And then we're going to interjoin with table 2 on, and then where table 1's column 1 equals column 2's column 1. I know this looks a little hard to follow, but it's really not too bad. So here we will run an inner join between the class and classes table where the student counts are equal. Notice I'm using aliases here. When you're doing any kind of joins like this, you can shorten the name of your table here by passing in a space and an alias name. So we have class just C and class is CS, and we're bringing back the class ID from table C, which is class, and then class ID from class as, which is CS, and the same thing for the rest of the columns. So take a look at that and see what we're doing, and that's where the C, or the class student count, equals the class as student count. So it's important to understand those aliases. They can really help rather than just having to enter the full table name, which certainly can be a lot. So what we're going to do is essentially put the class table on the left and the classes table on the right. And we're going to bring back that intersection. So here are the records here. You can see we're getting the first 4 from class and then the last 4 from class as. And you can see here where the names, and you can see here where the student counts are equal. Now normally we wouldn't bring back both sets of columns, but in this case, just for illustration, we did that. There's nothing wrong with it, but it obviously brings back a lot of repeated data. In SQL, there is a left outer join. So with a left outer join, it is a joining of tables based on a condition. And with the left outer join, there is a table, the first table, or the table said to be on the left, where the conditions are evaluated for whatever condition is passed in with a table, a second table, or a table that's said to be on the right. With the left outer join, all of the records of the table on the left are returned. So even if there is a null condition associated with the condition.
Thanks for watching. Please like and share this video.
All of the records in the left table will still be returned. And that's useful because it gives the user or the programmer the opportunity to see where the condition is true and where we have null conditions. So if we take a look here at our left outer join, our table on the left is going to be class, and we are going to compare class with classes, and we're going to return where the student counts are equal, but we're also going to see where the student count columns have nulls. So we can see here we're getting back here where the student counts are equal, but notice here we're getting all of the records from the left table or the class table. We're going to see where the equality in this case returns null, which this can be useful because it's showing where the equality was true and where we had nulls. SQL also supports something called a right outer join, which is different from what we looked at in the left outer join. With the right outer join, again, there are said to be two tables, one on the left, one on the right. With the right outer join, only records that are matching the second table or table 2 or the table on the right are returned. So we won't see those null tables. We'll only see where there is a match between the two tables on the left and on the right. Here's our example again with the class and classes table. We have the right outer join. The table on the left is said to be class. The table on the right is classes. And here we are only going to return the records where there is a match with the table 2, or in this case the classes table or the table on the right. And here you can see right outer join. And if we go ahead and run this, we could see here that we only where there was a match in classes do we get records returned. So you can see here the different records that are returned. Still a useful query, but you have to know the difference between the left outer join and the right outer join. And just one thing to make note of, notice here what we're returning. We are returning the record IDs, which actually are telling us a lot here. Here we're saying typically we would return, well in this case we're the table on the left, we're looking for where table on the right matches, and so we would only return one of the columns for the table, typically the table on the left. It could be the table on the right though, so it's hard. We're returning all columns here for all tables, but notice here we are seeing the first 4 records of the table on the left and the last 4 records of the table on the right. So that may be important to know, to see where our conditions are true. And we can see other data here. But you want to certainly make sure that you are returning from the proper table or showing the columns from the intended table. That's important. So take a really close look at these columns and the tables and the records from each table that are returned. Again, we're calling them out up here. You can see how we call them out up here in the select clause. Another type of join which can be useful in SQL is the full outer join, and the full outer join involves the union of both tables and will return the union of the tables even if there is a null result. So it will return what is true, and it will return when there is a null result. And this can be useful if you need to evaluate the records that have null results. So let's have a look at an example. Here we need to union the right join and the left join. So we have the table on the left, and we're unioning, and that's a new word, the result with the table on the right. So here we're just going to return all of the columns, again, all of the columns. And we can see here from the classes table and the class table where the student counts are equal, and we will get the full union result. We go and run that. We can see here the table on the left here, which is classes, and the table on the right, which is class. And you can see here where there's not a match, we're getting the null result back. And this obviously can be quite useful. You can see here there's a match in these columns. The first, or in class ID 7, 8, 9, and 10, we actually have that match, 200, 210, 220, 230. But in the ID 2, 3, 4, 5, 6 on the table on the left, we have null results. Again, this can be quite useful for certain applications or certain reports. Another join in SQL is the cross join, and a cross join produces a result set in which every table is joined to every row in the other table. So you could see here from this illustration, all of the rows are joined, and then based on the condition, a result set of equality, inequality, whatever the condition that's passed in, that result set is returned. One thing about all these SQL joins that we discussed, the inner join, the left outer join, the right outer join, the full outer join, the cross join, is in many cases they will return similar result sets. It's really under certain conditions where they will actually return different result sets. So it's important to experiment a little bit and also understand what the joins are returning, what they're doing, and also do a little bit of research to figure out which of the joins are the best for your particular need. So let's take a look at the example of the cross join. So here we have the cross join, and we are again selecting our columns. We have our two tables. We are using these aliases so we can look at the result set and understand which column is coming from which table. We have our tables in here, and we're doing our cross join on these two tables, and we're looking for a condition where the student count in class equals the student count in classes. So let's go ahead and run this. And we'll see here that we're only bringing back records. So you can see here on class, we're bringing back record IDs 1 through 4. On class as, we're bringing back record IDs 7, 8, 9, and 10, where the student count is equal. So again, this can have a similar result set quite often with other types of join. So it's only going to be at very subtle times where these different joins will produce different result sets. So again, it's important to understand that. Thank you again for taking this course. Here is what we have covered in this course. We looked at functional dependencies, normalization, the database development process. We looked at database users and the way that we work with users. We looked at structured query language and data manipulation language. In our next session, we are going to do an exercise that will be our project. For future classes, please consider contacting Coding Boot Camps for private tutoring sessions for system administrators or other types of weekly or monthly plans for coaching sessions and tutoring sessions in the structured query language or the database program. Are some possibilities for next classes: introduction to the Linux operating system, learning PHP programming, web development with PHP and MySQL, learn Node.js and ExpressJS, and MongoDB. Once again, thank you for taking this course. It's been a pleasure working with you. Again, this course has been a presentation of Coding Boot Camps.